Hi guys, today we're going to put together the last few lessons all into one, and we're going to focus on how do we actually graph a whole parabola. Some quick reminders and announcements before we get started. Make sure that if you have questions, you are emailing me if you need help. Make sure you're using your school email address. You cannot log into the IT if you're not using your school address. It's not too late to turn in work for quarter 3 or quarter 4. There's never a reason to guess, leave blanks, or write IDK in an answer blank. Please email me or attend office hours to get your questions answered. And make sure you have out a pencil and paper and be ready to take notes and try the try problems as we go. Quarter 4 ends May 21st. If you're passing with a C or better by then, you're done. If not, you'll need to continue working for 2 more weeks, so let's get these assignments handed in. The bonus point project is due May 22nd at midnight. It's worth 20 points, and you can find the expectations and rubric for that project on the Haiku page. Struggles or celebrations. I really love hearing about your struggles and celebrations, even if it's just what you're up to or what you're watching on TV. Miss you all so much. Today, my husband and I went down to the city market this morning and walked around the circle and bought some lettuce and some tomatoes, and it was nice to get out of the house a little bit. If you do not know how to factor, use quadratic formula, find this line of symmetry or the vertex, this is not going to be good times for you. Stop here, go back to Haiku, and redo the last lessons on factoring, quadratic formula, line of symmetry, and the vertex. Then I want you to attend an office hour with me. Riverside does pay me money to help you. It's my job. It's not bothersome for you to get onto my office hours. I'd love to help you. All right, some quick review from the last lesson. Characteristics of a parabola. Remember, your direction can either be up like a cup or down like a frown, and you're looking at A. In this case, our A is positive, which is why this is up like a cup. The x-intercepts, which are the zeros, we can either get by factoring or using the quadratic formula. In this case, the zeros are -1 and 3. The y-intercept, which we can find, we'll talk more about that today, is a dot that's on the y-axis. In this case, the y-intercept, or our b, which I should probably write, is -3. The line of symmetry cuts through the middle of our parabola, cuts down right through here, and we can find that using the equation -b/2a. In this case, it is equal to 1. And the vertex always comes from our line of symmetry. In this case, it is 1, -4. And that's all review. So if you're struggling with any of that, you should go back to the last couple lessons and use those to get you some help. So last time we worked on making a rough sketch. We found the zeros, we found the line of symmetry, we found the vertex. So we can compare what our graph looks like to what a perfect version of that graph looks like. We can do better. So today is all about being able to flesh this out and make it into a little bit more of a curve instead of a V shape or an approximation. So suppose we want to graph our equation y plus 3 equals x squared plus 4x. So the first step is to put this into standard form. So I want the y to be isolated. So I'm going to subtract 3 from each side. And so y equals x squared plus 4x minus 3, and then I want to replace y with 0. So we have x squared plus 4x minus 3 is equal to 0. A is our invisible 1 that's in front of our x squared, b is 4, and c is -3. So now we find our x-intercepts by substituting 0 for y, which you and I already did on the last screen. We got 1x squared plus 4x minus 3. And then this is where we're either going to use factoring or the quadratic formula. I always think factoring is easier if it's possible. Unfortunately, factoring is not always possible. So let's see if it is. We're going to multiply a times c. So we do 1 times -3 and get -3. We're looking for two numbers that multiply to be -3 and add to be 4. So what we've got is 1 times -3. Nope, that would add to be -2. Positive 3 times -1. Nope, that would add to be +2. So it looks like it's not factorable, which means we have to use quadratic formula. So that becomes -b plus or minus square root of b squared, which is why I turned that into 16, plus -4, it's always -4 there, times a times c, all over 2 times a. We always simplify what's inside the radical first, so it's negative 4 plus or minus the square root of 16 plus, and then negative 4 times positive 1 times negative 3 is positive 12 all over 2. So this turns into negative 4 plus or minus the square root of 28 all over 2. Now we're just going to use our calculator to help us simplify. So this is negative 4 plus or minus. I find the square root of 28. I just need to round to the nearest tenth. It's 5.29, so I'm going to write that as 5.3 divided by 2. And now we split it up into two problems. It's either negative 4 plus 5.3 divided by 2, or negative 4 minus 5.3 divided by 2. Negative 4 plus 5.3, and then hit enter, divided by 2, gives me 0.65, so I'm going to round that to 0.7. Negative 4 minus 5.3 and hit enter, which gives me negative 9.3, divided by 2 gives me negative 4.65, which I'm going to round to negative 4.7. So those are my zeros. I tried factoring, it didn't work, so I had to go to the quadratic formula. Now we're going to find our x-coordinate using x equals negative b over 2a. This is also what we call our line of symmetry. So this is our b, this is our a, but it's negative 4 all over 2 times that invisible 1. So it's negative 4 divided by 2, which is negative 2. That's our line of symmetry, so x equals 2. I'm sorry, x equals negative 2. And then we find our y-coordinate for that by substituting the x value back into the original equation. So it's negative 2 squared plus 4 times negative 2 minus 3. Negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8 minus 3. So 4 minus 8 is negative 4. Negative 4 minus 3 is negative 7. So the vertex comes from our x value, which was negative 2. And so our y value is negative 7. So here's what we know so far. We had a 0 at 0.7 comma 0 and a 0 at negative 4.7 comma 0. So both of those dots are on the x-axis right now. We've got a line of symmetry where x is equal to negative 2. And we've got a vertex at negative 2 comma negative 7. You should be able to see that it opens up like a cup if I were to sketch this in. But right now, there's really nothing that stops us from turning this into a V shape. What we can do is get a little bit more information. We can substitute some numbers in on either side of the line of symmetry. So here's our vertex, negative 2 comma negative 7. Here is our 0, negative 4.7 comma 0. And 0.7 comma 0. What I've done is create a table. So if you're going to draw this on your own, you would have 3 columns. Sorry, it's hard for me to make straight lines on this. And you would be substituting in those numbers into that. So let's see, what's something that's to the left? It would be negative 5. What's a number that's in between negative 2 and negative 4.7? Let's use negative 3. And a number in between 0 and negative 2, we'll use negative 1 there. So let's try our negative 5 first. Remember, this equation tells me how can I substitute in x and get y. So what I'm doing is replacing x with negative 5. So this becomes negative 5 squared, which is 25, plus 4 times negative 5, which is negative 20, minus 3. 25 plus negative 20 is 5. 5 minus 3 is 2. So that becomes negative 5 comma positive 2. Now, what I'm going to do is cheat here. I'm going to use my line of symmetry. Rather than calculate all of these things, I'm going to use my line of symmetry to make some calculations. So I notice that this dot is 1, 2, 3 spaces away from the axis of symmetry. So I'm going to go 1, 2, 3 spaces on the other side, and so I know that there is a point at 1, 2. I used my line of symmetry to do that. So I don't need any work for that. I use symmetry to get that number. So that helps to fill in part of my table. Okay, let's do the same thing for negative 3 now. Negative 3 squared is positive 9. 4 times negative 3 is negative 12. Bring down the minus 3. 9 minus 12 is negative 3. Negative 3 minus 3 becomes negative 6. So this is negative 3 comma negative 6. So we've got a point at 0, 1, 2, negative 3, 1, 2, 3, 4, 5, 6 right here. And again, I'm going to cheat and use my line of symmetry to help me find another point. This is one space away from the line of symmetry. So on the other side, I can go one space away and put another point. That's also the point, negative 1 comma negative 6. And I used symmetry to get that. I don't have to include any work there because I used symmetry to get it. Now we can see that this looks a little bit more like a curve. If I was a better artist and could draw straighter lines with this tablet, it would be better. All right, so here's a better shot of the numbers that we found. We used our line of symmetry to get our numbers there. They used negative 6 instead of negative 5 like I did, but it's the same idea. We put those points in, and now we can put in our graph, and it looks like a much nicer curve instead of a V shape there. So really all that we've added in today is being able to substitute in other numbers to substitute into the equation to flesh out our parabola. So let's try one. First of all, let's get this in standard form by adding 5 to each side. So this becomes y equals negative 1x squared plus 4x plus 5, and I'm going to replace y with 0. So it's negative 1x squared plus 4x plus 5. A is negative 1, B is 4, and C is 5. I'm always going to try factoring first. I'm looking for two numbers that multiply to be negative 5 but add to be 4. Let's try maybe negative 1 and 5. Negative 1 times 5 is negative 5. Negative 1 plus 5 is 4, and it does work. So now I'm going to replace b with the magic numbers. This becomes negative 1x squared, and instead of 4x, it's going to be minus 1x plus 5x plus 5 at the end. That's all equal to 0, so now I'm going to factor using grouping. I'm going to factor out a negative 1x because both of these can be divided by negative 1x. Negative 1x squared divided by negative 1x gives me positive x. Negative 1x divided by negative 1x is positive 1. Anytime we divide something by itself, we get positive 1. Here, the GCF is 5. Both of these are divisible by 5. 5x divided by 5 is x. 5 divided by 5 is 1 because anything divided by itself is 1. And that's still equal to 0. My factors now become negative 1x plus 5, and x plus 1 is equal to 0. And I split those into two pieces. Negative 1x plus 5 equals 0, and x plus 1 equals 0. Minus 5 from both sides gives me negative 1x is equal to negative 5, and so x equals 5. Oops, sorry, x equals 5. Minus 1 from both sides, so x equals negative 1. Now we're finding our vertex. We put in our negative b, so b is 4, so that becomes negative 4 over 2 times negative 1. Negative 4 divided by negative 2 is positive 2. That's our line of symmetry, x equals 2. And to find our vertex, we substitute into the standard form, so y equals negative 1x squared plus 4x plus 5. We now know that x is 2, so it's negative 1 times 2 squared plus 4 times 2 plus 5. We do exponents before we multiply. 2 squared is 4. 4 times negative 1 is negative 4. 4 times 2 is 8. Bring down the plus 5. Negative 4 plus 8 is 4. 4 plus 5 is 9 there. All right, make sure you have this stuff written down before we move on. We're going to stop here, and we're going to go back to Haiku and go to part 2 of the video today because we're almost at our 15 minutes for this one. All right, see you in a few.